I want you to imagine something. Can humanity really build a city on the moon? Picture the grey moon, floating in the jet-black expanse of space. And upon it, the lights of a human city twinkling in the future. Is this a mere fantasy, or is it a plan that is gradually becoming a reality? The truth is, more than 50 years have passed since the Apollo program, and we still do not have a permanent settlement on the moon. However, as we entered the 2020s, agencies like America's NASA and the European Space Agency, or ESA, have begun to move in earnest to send humans back to the moon and establish a base. Behind this push are a new space race, advancements in science and technology, and a grand vision for the future of humanity. Why are humans trying to live on the moon? With this question as our hook, let's begin to unravel this story. A lunar city is not just a dream from science fiction based on the latest research and plans, such as NASA's Artemis program and ESA's Moon Village concept. We will explore the possibility of humanity building a city on the moon. In the past, with Apollo 11 in 1969, humanity first set foot on the moon. And by the final mission, Apollo 17 in 1972, a total of 12 astronauts had walked on the lunar surface. But why has no one been back since? One reason is that after the Apollo program ended, budgets and political interest waned, leading to a stagnation in lunar development. Additionally, the technological challenges of sustaining human life on the moon were immense, and the hurdles were extremely high at the time. However, circumstances changed in the 21st century, with the rise of private space companies and the entry of new nations into space exploration. The moon is once again in the spotlight. Will the next human footsteps be on the moon or on Mars? In response to this question, NASA launched the Artemis program, deciding to return humanity to the moon. Furthermore, countries like China and India have also shown ambitions for lunar exploration and base construction, creating the appearance of a new space race. The risk of China getting to the moon first is even being debated in the U.S. Congress. In this video, we will weave a story that begins with the why of the lunar city concept, explores the what and how of its realization, and delves into the challenges, future visions, and even the philosophical meaning behind it all. We will take you on a journey that will tickle your intellectual curiosity. By the end, change the way you look at the moon. So, let's embark on this journey of exploration together. The necessity of a city on the moon. Why the moon? When considering places for humanity to live beyond Earth, various candidates come to mind, such as Mars or space stations. However, the moon is overwhelmingly closer and offers many advantages compared to them. Here, let's consider the significance and necessity of building a city or base on the moon. First and foremost, the greatest advantage is its proximity. The moon is about 380,000 kilometers from Earth, a distance of just 1.3 seconds. At the speed of light, the Apollo spacecraft reached the moon in about 3 days. Mars, on the other hand, is tens to hundreds of millions of kilometers away, and a trip there would take from 6 months to over a year. The difficulty of returning to Earth in an emergency is also orders of magnitude different. Therefore, the moon is like Earth's cosmic backyard, making it the most realistic place to first establish long-term habitation technology. Next, the Moon possesses valuable resources. The most prominent of these is water ice, while the lunar surface has no atmosphere or liquid water. Recent explorations have revealed that large quantities of ice are buried in the permanently shadowed craters of the polar regions, where sunlight never reaches. For instance, the presence of water was confirmed when NASA's L-Cross mission intentionally impacted a crater. Water is not only essential for human life support, but can also be broken down into oxygen and hydrogen through electrolysis. Oxygen can be used for breathing, while the vast amounts of hydrogen and oxygen can serve as rocket fuel. Securing water resources on the Moon would mean we wouldn't have to transport everything from Earth. This is crucial for drastically reducing the costs of space exploration and making the Moon a relay station for deeper space missions. Furthermore, the resource called helium-3 is also gaining attention. Helium-3 is extremely rare on Earth, but it is believed to have accumulated on the Moon's surface over billions of years. Deposited by the solar wind, it is considered an ideal fuel candidate for future nuclear fusion power, as it is expected to produce clean energy with almost no radioactive waste. If a fusion reactor using helium-3 and deuterium becomes a reality, it has the potential to generate enormous amounts of energy. At present, nuclear fusion power itself is still in the research phase, and the utilization of helium-3 remains hypothetical. But it is still cited as one of the significant reasons for building a lunar city, a dream resource. The role of the Moon as a forward base for space exploration cannot be overlooked. NASA positions the Moon as a proving ground for the exploration of Mars, because the Moon's gravity is 1/6 that of Earth's. Launching rockets from the Moon in the future would require less fuel than launching directly from Earth into deep space. Moreover, accumulating know-how on long-term habitation, life support, and settlement on the lunar surface will be a significant asset when humanity eventually heads to Mars and even more distant planets. In NASA's own words, the Moon is a gateway to the solar system and a stepping stone to expand humanity's horizons. From a philosophical perspective, there is also the meaning of expanding humanity's sphere of survival. Considering the resource and environmental problems on Earth, the question arises as to how long humanity can rely solely on our home planet. In the event of a catastrophic event on Earth, such as a giant meteorite impact, climate change, or a global pandemic, having a settlement off-world could be a meaningful backup. To preserve human civilization, the Moon can be seen as the closest safe haven from Earth. Thus, the question of why build a city on the Moon has multifaceted answers. Because it's close, because it has resources, because it can be an exploration base, and for the future of humanity. A lunar base is not just a scientific challenge. It is a project that holds a crucial position in humanity's future strategy. So, how are these plans actually progressing? In the next chapter, we'll take a detailed look at the NASA-led Artemis program, including the latest updates. The NASA Artemis program. Have you ever heard the term Artemis program? Artemis is the name of the Greek goddess of the Moon, and it's the name given to NASA's human lunar exploration program. In short, it is the plan to send humans to the Moon for the first time since Apollo, this time with the goal of long-term habitation. Here, let's examine the overall picture and latest developments of the Artemis program. The Artemis program overview. The Artemis program proceeds in stages. First, Artemis 1, conducted in 2022. was an uncrewed test flight of the Super Heavy Lift rocket, the Space Launch System, and the new Orion spacecraft. It was a success, with the Orion spacecraft orbiting the Moon uncrewed and returning to Earth. Next, in Artemis 2, 4 astronauts will board Orion for a crewed flight test, orbiting the Moon and returning to Earth. According to the latest schedule, Artemis 2 is planned for launch in April of 2026, and then with Artemis 3, the first crewed lunar landing since Apollo 17 is targeted, originally set for 2024. The schedule has been revised, and the current outlook is for the first Artemis lunar landing to take place around 2027. In Artemis 3, one of the astronauts is planned to be the first woman to explore the lunar surface. They will land near the Moon's south pole and conduct scientific research during a stay of about 1 week. Why the South Pole? Because, as mentioned in the previous chapter, it has a high probability of containing water-ice resources, making it suitable for future base construction. What makes the Artemis program fundamentally different from the Apollo era is what comes after. The Apollo program ended with one-time visits, but Artemis aims for sustainable and continuous human presence. In other words, the long-term goal is to conduct crewed flights to the Moon almost annually after Artemis 3, develop a foothold, and ultimately establish a permanent lunar base called the Artemis Base Camp. The role of the Gateway Lunar Orbiting Outpost. One of the key elements of the Artemis program is a lunar orbiting outpost called the Gateway. The Gateway is a small space station to be constructed in lunar orbit, which you can think of as a miniaturized version of the International Space Station, or IS. Why is an outpost in lunar orbit necessary? It's to function as a staging point for travel between the lunar surface and Earth. In the Artemis program, the procedure involves astronauts traveling from Earth to the Moon in the Orion spacecraft and docking with the Gateway in lunar orbit. They would then transfer to a human landing system, which would be waiting at the Gateway to descend to the lunar surface. The Gateway will serve as a place to store fuel and supplies needed for landing on and taking off from the Moon, as well as a habitat for astronauts and a laboratory for scientific experiments. Also, going through the Gateway first, rather than landing directly on the Moon from Earth, offers advantages in flexibility and safety. The Gateway is a U.S.-led but international cooperative project. For instance, the European Space Agency, ESA, is scheduled to provide a refueling module, ISPRIT, and a habitation module, IHAB. Canada will develop and provide a new robotic arm, Canadarm3. Japan's JAXA is also participating in the development of a habitation module, and the participation of Japanese astronauts in future lunar missions is anticipated. Artemis is progressing under an international framework called the Artemis Accords, and as of 2025, over 25 countries have signed on to its principles. It is an agreement that sets rules for the peaceful use of outer space, cooperation, and resource utilization. However, it was once reported that the Trump administration had announced the cancellation of the Gateway project due to subsequent plan revisions and budget changes. It is possible that its development is currently in flux. Latest developments on lunar landers and exploration rovers. The lunar lander for the Artemis program has a very different appearance from the one used in the Apollo missions. NASA adopted a policy of entrusting the development of the lunar lander to private companies to incorporate their ideas and promote competition. In 2021, the Starship from the space company SpaceX was selected as the first lunar lander. The Starship HLS is a version of the company's super heavy lift spacecraft. Starship, modifié for lunar landing. It is a massive lander capable of carrying multiple astronauts and a large amount of cargo at once. The plan is for it to travel uncrewed to the Gateway in lunar orbit, where it will meet the astronauts and descend to the lunar surface. SpaceX's Starship is reusable and capable of mass transport. So, if realized, it is expected to significantly advance the transportation of supplies and the construction of a base on the Moon. Furthermore, in 2023, a second lunar lander from Blue Origin, the space company founded by Jeff Bezos, who also founded Amazon, was selected by NASA. This lander is expected to be used for Artemis 5 and beyond. Securing multiple lander options helps to distribute risk and increase the flexibility of the overall program. Development of lunar exploration rovers is also underway. For Artemis, a new crewed rover called the Lunar Terrain Vehicle, or LTV, is planned. This is equivalent to the lunar rover of the Apollo era, but is being designed for longer-term use with recharging capabilities. Allowing astronauts to explore farther, NASA aims to deliver this rover to the Moon in the late 2020s for astronauts to use. Additionally, Toyota and JAXA have announced the concept for a pressurized rover called the Lunar Cruiser. This is proposed as a mobile base that future astronauts can ride in a shirt-sleeve environment, meaning without wearing a spacesuit. It uses fuel cell technology and is envisioned as a base that can traverse the Moon for weeks at a time. In terms of exploration, NASA was developing an uncrewed rover called Viper. Viper was scheduled to investigate the distribution of water and other volatile substances near the Moon's south pole. But in July of 2024, the mission was officially cancelled by NASA. Currently, Viper's development is already complete, and NASA is considering reusing its instruments and components in future lunar exploration missions. The scientific objectives of Viper, such as mapping ice and investigating volatiles, are being considered for transfer to other programs. The Griffin lander is still aiming for a landing in the Moon's south polar region in 2025, but it will not carry Viper. Another rover is expected to be used instead. This remains a crucial mission to detail where and how much water resource exists for future crewed base construction. The Griffin lander is a large lunar lander being developed by the American space company Astrobotic, an uncrewed lander intended to transport scientific instruments and rovers to the Moon's south polar region. As part of NASA's Artemis program, the vision for the 2030s Artemis Base Camp. The ultimate goal of the Artemis program is to build a sustainable base on the Moon in the 2030s. NASA calls this vision the Artemis Base Camp. The base camp is said to have three main elements: a foundational habitat, which is a habitation module where a crew of 4 can live for 1 to 2 months, with the potential for future expansion by connecting multiple modules, a lunar terrain vehicle, a small, uncrewed or crewed rover for astronauts to move around the base, and a habitable mobility platform, a mobile home like a pressurized rover or mobile habitat. This would allow for research trips lasting several weeks to locations tens of kilometers away. The base camp is proposed for the vicinity of the Moon's south pole. For example, near Shackleton crater. The reasons, as mentioned before, are access to water resources and the proximity of terrain where sunlight can be easily secured. On the highlands of the South Pole, there are so-called peaks of eternal light, where the sun rarely sets. In the initial missions, the lunar lander itself will double as a habitat. But gradually, base infrastructure will be transported, and by the 2030s, the facilities of the base camp are planned to be established over multiple missions. For instance, there is a plan for Artemis 4 to launch the Gateway's habitation module, IHAB, while also delivering supplies to the lunar surface. Artemis 5 is planned to see the deployment of the European refueling module, Canada's robotic arm, and NASA's LTV all at once. In this way, the infrastructure will be expanded with each mission and the prospect of full-scale, long-term stays on the Moon is expected to be realized from the mid-2030s onward. NASA itself positions this as the beginning of a new generation of exploration, called the Artemis generation, and even proclaims that our success will change the world. The Artemis program is not just a scientific exploration, it is a crucial step towards opening up a future space economy and sending humanity to Mars. The above is an overview and the latest information on the NASA Artemis program. Now, how is a lunar city being discussed from a non-American perspective? In the next chapter, we will look at the Moon Village concept proposed by the ESA, the European Space Agency. ESA's Moon Village concept, whereas the Artemis program is a collection of specific missions. The Moon Village concept proposed by ESA is a more relaxed vision. It was proposed around 2015 by the then Director General of ESA, Johann Dietrich Werner, as an idea to build a village on the Moon through international cooperation. The term village doesn't mean building a community with houses and shops from the outset. Rather, it's a flexible concept of an open architecture, where various countries and companies can participate in lunar activities, eventually integrating them to form something like a single village. The characteristics of the Moon Village concept are its openness and inclusiveness. Any country or organization can participate, whether with robotic or crewed missions. Various activities, from scientific research and resource mining to tourism, can take place on the Moon, and they are envisioned to cooperate and link together loosely. In essence, the Moon Village is a vision, not a plan. It is not a project with a fixed timetable or budget. However, through this vision, ESA aims to stimulate interest in the Moon among various nations and promote international collaboration. The idea is that if the world could cooperate on the International Space Station, the next step is to do it on the Moon. So, how is a lunar base envisioned to be built under the Moon Village concept? The keyword is in situ resource utilization. If we were to transport all the bricks and cement from Earth to build a house on the Moon, the cost would be astronomical, and sustainable development would be impossible. What is being considered here is using the lunar soil, or regolith, to create the base's structures. Construction technology using 3D printing and regolith. In recent years, the application of 3D printing technology to space has been gaining attention. Research institutions around the world, including ESA, are studying whether buildings can be constructed using the lunar regolith, the sand and fine dust on the Moon's surface, as a material. For example, there is a method called solar sintering, which involves melting and solidifying regolith at high temperatures to create brick-like blocks or domes. By using large lenses or mirrors to focus sunlight to a single point, the lunar soil can be melted and solidified, creating a hard, structural material like concrete on site. This technology, in theory, does not require cement paste, which is a mixture of cement and water, can be used in the vacuum of space, and is promising for creating the foundations of a lunar base and walls to shield against radiation. Also being considered is the additive manufacturing method, commonly known as 3D printing, where a thin layer of powder is spread and then sintered with a laser, building up layers. In ESA's research, scenarios are being considered where not only structures, but also tools and replacement parts are manufactured on site from regolith. If such technologies are established, it might become possible for a lunar base to be self-sufficient in terms of its large residential domes and most of its equipment, with only personnel and advanced machinery being transported from Earth. Reducing dependence on resupply from Earth is essential for a sustainable lunar city. And 3D printing with in-situ resource utilization could truly be a game changer. Here is an artist's conception of a future lunar base. Expansive solar panels supply energy. Plants are grown in dome-shaped greenhouse facilities, and habitation modules are covered with regolith for radiation protection. The Moon Village concept aims for countries to cooperate and gradually develop such a base. Energy supply solar and nuclear power. In a lunar city, energy supply is a matter of life and death. In the Moon Village concept, the first thing that comes to mind is solar power generation. The moon has no atmosphere and no clouds, so sunlight is strong and can be efficiently converted into electricity, particularly at the lunar South Pole. There are areas on crater rims that receive almost constant sunlight, and plans are being considered to install large-scale solar panels there. The electricity generated would not only be used for the base's life support and equipment, but also for resource utilization processes, such as the electrolysis of water. However, since the lunar night lasts for 2 weeks, energy storage and alternative power sources are essential. What's being considered here is the use of nuclear power. Specifically, there is a proposal to install small fission reactors at the base to supply power continuously. NASA is also advancing a plan to experimentally install a small lunar reactor, the kilopower reactor, in the late 2020s, with the aim of operating it until around 2030. Small reactors, with an output of about 10 kilowatts, can operate regardless of day or night, supplying power to the base even during the long lunar night. Furthermore, the possibility of fusion reactors using the aforementioned helium-3 is also discussed for the future. If nuclear fusion becomes practical, the science fiction-like plan of bringing helium-3 from the moon to generate power on Earth might become a reality. However, in reality, the commercialization of fusion power is likely a long way off, and the hurdles of operating a huge plant on the moon are high. Nevertheless, the Moon Village concept includes the grand vision of the moon as a future energy base, the philosophy of a shared city. If one were to describe the Moon Village succinctly, it is the idea of a shared lunar city, not a base of a specific country, but an open village where all willing nations can participate. For example, one country might transport supplies by rocket, another might provide habitation modules, and a company might build the communication infrastructure, creating a single, large community through a division of roles. The idea is that the moon belongs to no one and is the common heritage of mankind. So we should develop it cooperatively. In fact, while the ongoing Artemis program involves multinational cooperation, it is led by the United States. The Moon Village concept is more flexible and is open to the participation of non-governmental entities, such as private companies and universities. This approach can be called a space version of open innovation, and it is expected to lead to unprecedented development by gathering wisdom and resources broadly. Also, the emphasis on cooperation rather than competition is a philosophy that connects space development to peace and prosperity on Earth. Although the Moon Village concept has no definite timeline, ESA and related organizations are steadily refining the concept by holding workshops and international conferences based on this vision. In the future, it may merge and evolve with existing initiatives like the Artemis program, leading to the birth of a truly international lunar city, an Artemis base plus a moon village. Next, we will turn our attention to the scientific challenges that stand in the way of realizing these lunar city concepts. Living on the moon is not all rosy. There are harsh environmental conditions that must be overcome. Scientific challenges behind the romance of building a city on the moon and people living there. There are numerous scientific challenges that must be solved. Here, we will discuss the main challenges: radiation, low gravity, the temperature environment, and the dome concepts designed to protect the living space from them. The radiation problem, protecting ourselves from cosmic rays and solar wind. The reason we can live safely on Earth is thanks to the dual shields of our atmosphere and magnetic field, which protect us from harmful cosmic radiation. However, the moon has almost no atmosphere and no magnetic field. Therefore, radiation from space, such as galactic cosmic rays and solar radiation, directly reaches the lunar surface. Cosmic rays are high-energy particles accelerated by distant supernova explosions and other phenomena, which can damage DNA, increasing the risk of cancer, and are also suggested to have long-term effects on the central nervous system. Additionally, solar flares and coronal mass ejections associated with solar activity can cause temporary, intense bursts of high-energy particles, known as solar cosmic rays. This poses a risk of receiving a lethal dose of radiation in a short time. To be specific about the radiation levels on the moon, according to data from a dosimeter on China's Chang'e 4 lunar lander, a German research team reported that there is an exposure of about 60 microsieverts per hour on the lunar surface. This is about 200 times the level on the Earth's surface. At first glance, this seems like an enormous number, but it is only about 2.6 times what astronauts on the International Space Station are exposed to, so it is not a level at which people cannot immediately be active. However, for a long-term stay, it's a different story. NASA's career radiation exposure limit for astronauts is generally in the range of several hundred millisieverts, though it varies by gender and age. A simple calculation shows that spending 1 year on the moon would result in about 500 millisieverts of exposure, approaching the limit. Therefore, in a lunar city, measures to protect against radiation are essential. One solution is to cover the living spaces with lunar soil. Regolith acts as a natural radiation shield. By placing habitation modules under a few meters of regolith, most of the cosmic rays can be blocked Materials with high hydrogen content, such as water and polyethylene, are also effective for radiation shielding in a lunar city. Designs are being considered where bags filled with regolith or water tanks are placed on top of habitation domes and modules. In fact, NASA's conceptual designs also depict the idea of covering living quarters with regolith. Another option is the use of underground spaces. It has been pointed out that the moon may have caves formed by flowing lava, known as lava tubes. If such natural caves or underground voids exist, they could serve as ideal shelters, protected from radiation and micrometeoroids. There are also concepts for exploring and utilizing these to create an underground lunar city in the future. What is crucial is the response to emergencies like solar flares. In the event of a powerful solar storm, astronauts must immediately take refuge in a heavily shielded shelter. A lunar base would need to be equipped with emergency radiation shelters, and a safety protocol would be required where solar activity is monitored in real time, and an evacuation order is given upon alert. The challenge of 1/6 gravity effects on the human body. The moon's gravity is only about 1/6 that of Earth's, approximately 0.165 g, while not as extreme as zero gravity. Living in this low-gravity environment for an extended period causes various changes in the human body. The most significant concerns are bone and muscle atrophy. On Earth, our muscles and bones are constantly under load as they support our bodies against gravity. But on the moon, this load is significantly reduced, as astronauts experience during their stays on the ISS. Unused muscles weaken, and bone density decreases. In fact, on the zero-gravity ISS, countermeasures include more than 2 hours of daily exercise, such as running on a treadmill and strength training. But even this cannot completely prevent it. On the moon, although it's 1/6 g, it's still low enough that similar measures will be necessary. The weaker gravity also changes the distribution of body fluids. Blood tends to pool in the head, and effects such as a disturbed sense of balance are also conceivable. After a long stay on the moon, it may take time to readapt to Earth's gravity upon return. Conversely, if children were to be born and raised on the moon in the future, their skeletons and musculature might be quite different from those of Earthlings. It's even possible they wouldn't be able to withstand their own weight upon coming to Earth. Such medical and biological challenges must also be considered when discussing a lunar city. As countermeasures, regular exercise is a given. But in the future, the introduction of artificial gravity is also being considered. For example, there is an idea to create a gravity close to 1 g through centrifugal force by making the living quarters a large rotating dome. However, this is large scale and complex, making it difficult in the near future. Realistically, the approach will likely be to manage with tailored exercise and nutrition for astronauts, and if necessary, using medication to suppress bone loss. Extreme temperature differences, the problem of lunar day and night. Another harsh aspect of the lunar environment is the extreme temperature difference. Because the moon has no atmosphere, the temperature varies greatly between sunlit and shaded areas. Near the equator, daytime temperatures can reach 120 degrees Celsius or 248 degrees Fahrenheit, while at night they can plummet to -170 to -180 degrees Celsius. or around -274 to -292 degrees Fahrenheit. Moreover, a lunar day is about 27.3 Earth days long, meaning that the sunlit daytime lasts for about 14 days, and the sunless nighttime also lasts for about 14 days. This cycle of a 2-week day and a 2-week night is a major challenge, especially the cold and darkness of the long night, which is the greatest trial for a lunar base. The high temperatures during the day are also a problem. In the sun, the lunar surface becomes scorching hot due to intense direct sunlight. Spacesuits and base equipment need insulation and cooling mechanisms to withstand these high temperatures. Electronic equipment is also prone to malfunction at high temperatures, so thermal design is crucial. However, the cold of the night is even more severe, with extremely low temperatures below -170 degrees Celsius lasting for 2 weeks. The living quarters must be continuously heated, which consumes a vast amount of energy. It is unrealistic to rely solely on batteries for 14 days. So plans are being devised to get through the night using the aforementioned nuclear power sources or fuel cells. Even so, outdoor activities at night would be almost impossible. Mechanical systems would also suffer, with oil freezing and battery efficiency dropping. So, operations might be designed to essentially hibernate at night. To solve this day-night problem, the Moon's south pole is a promising location in certain high-altitude areas of the South Pole. The sun moves along the horizon, so some part is almost always illuminated, and these are expected to be regions of near constant sunlight. While not 100%, this could significantly shorten the duration of the night, making it much easier to secure energy. Also, since there is ice in the permanently shadowed craters of the South Pole, water and fuel can also be secured. It's a 2-for-1 deal, which is why both NASA and ESA are focusing on the vicinity of the South Pole as a candidate site for a lunar base. Dome concepts to protect living spaces. To protect humans from such a harsh environment, the concept of a domed lunar city has been envisioned for a long time. A city covered by a transparent dome. You might have seen it in science fiction movies. In reality, creating a complete glass dome is difficult due to issues with material strength and radiation. But there are several ideas, such as semi-subterranean domes. For example, one idea is to excavate a crater on the lunar surface, place habitation facilities inside, cover it with a dome, and then cover the surface with regolith for shielding. This dome would maintain the same air and pressure as Earth, creating a shirt-sleeve environment where people can walk around without worrying about the vacuum or harsh temperatures outside. Plants could be grown and water could be recycled inside. If a lunar city were to grow to a scale of several hundred people in the future, an approach of covering the entire city with such a large dome might be considered. In fact, in a lunar city competition in the 2010s, a Japanese construction company proposed a concept for an underground lunar city with drawings depicting residences and parks inside a giant dome. It's still a pipe dream, but with the advancement of technology, it might one day become a reality. Alternatively, there is research into generating a magnetic field to artificially deflect cosmic rays, whether it's a dome or a magnetic bubble. It is necessary to create an environment where humans can live safely and comfortably. We have looked at the 3 major challenges: radiation, gravity, and temperature. Overcoming them is not easy. but technology is advancing step by step. In the next chapter, we will delve into the topic of self-sufficiency, which is indispensable for a lunar city. A system for recycling resources locally is the key to living on the moon, the future of resources and self-sufficiency. To sustain a lunar city, it is crucial to be as self-sufficient as possible. Transporting large quantities of supplies from Earth each time is not only financially unfeasible, but also carries the risk of not being able to rely on it in an emergency. Here, we will explore the future vision of how to secure and produce the resources essential for life support: water, air, and food on the moon. Securing water in search of polar ice. Water is the source of life and the most important resource for a lunar base. As mentioned before, the polar regions of the moon contain ice, or frozen water. In 2018, an analysis of data from the Chandrayaan-1 mission reported the direct detection of ice inside craters at the moon's north and south poles. NASA also confirmed the presence of water with the L-Cross experiment. So, how do we use this ice? First, we need to find it. NASA's uncrewed rover, Viper, was designed for exactly this purpose. And in the future, ice mining robots will likely be developed. The ice is thought to be finely mixed with the soil of the craters, and a process is being considered where the excavated regolith is heated to extract water vapor, which is then cooled to obtain water. This is like building a refining plant on the moon. The water obtained can be used directly for drinking or growing plants. Additionally, some of it can be broken down into oxygen and hydrogen through electrolysis. The oxygen can be used for breathable air, and the hydrogen and oxygen can be used as fuel for fuel cells or, in the future, as rocket fuel. In other words, if we can secure water, we can obtain air, water, and fuel. This will be the core of lunar resource utilization. Oxygen production, making air from regolith. Oxygen for breathing is also essential. In fact, the lunar soil, or regolith, contains a large amount of oxygen in the form of compounds. The main components of regolith are oxides, such as silicon dioxide and iron oxide, in which oxygen atoms are trapped. Therefore, technologies are being devised to extract and produce oxygen from regolith. In 2023, a NASA research team succeeded in extracting oxygen from simulated lunar soil in a vacuum. They melted the regolith in a high-temperature furnace and added carbon, causing a process called carbothermal reduction, which generated carbon monoxide. This was evidence that oxygen had been extracted from the soil, and by further processing the generated carbon monoxide, oxygen can be obtained. This experiment was conducted in a vacuum chamber that simulated the lunar environment, demonstrating for the first time that humanity can produce oxygen on the moon. Other methods being researched include molten oxide electrolysis, where electricity is passed through molten regolith to release oxygen gas, and high-temperature reduction with hydrogen gas. All have their challenges. But if a technology to obtain a large amount of oxygen at once is established, the air and rocket fuel for a lunar city could be supplied locally. According to ESA's estimates, a lunar factory could potentially produce several hundred kilograms of oxygen annually. As a byproduct of oxygen extraction, metal powders, such as iron and aluminum, are obtained. These could be used as metal resources for construction materials or tool manufacturing at the base. It's a 2-for-1 process. Food production closed-loop ecosystems and plant factories to live for a long period. We would also want to produce food locally. On the moon, we can't create farmland, so the methods are limited. But the most promising is a greenhouse-style plant factory. As mentioned before, the Moon Village concept also includes drawings of growing plants in a dome-shaped greenhouse. NASA and other space agencies have been working on plant cultivation in space for many years. On the ISS, lettuce and other vegetables have been grown in a device called Veggie and have been eaten by astronauts. For full-scale agriculture on the Moon or Mars, cultivation experiments using simulated lunar and Martian soil have also been conducted. The results confirmed that although lunar soil lacks nutrients, plants can grow in it. However, hydroponics or aeroponics would be more efficient than using lunar soil in pots. In the United States, the University of Arizona and NASA are collaborating on an experiment for a closed-loop ecosystem. This is a system that utilizes the cycle where plants absorb CO2 and produce oxygen, and humans breathe the oxygen and exhale CO2, with water also being recycled. Specifically, the astronauts exhaled CO2 is sent to the greenhouse. Plants convert it to O2 through photosynthesis and return it to the astronaut. Water is circulated for drinking by humans and for the plants, and the light for plant growth is provided by LEDs or sunlight. In a way, it is an attempt to create a miniature Earth ecosystem within the base. In the experiment, a hydroponic system is placed in an inflatable cylindrical greenhouse, and various plants such as lettuce, tomatoes, and sweet potatoes are grown. The challenges are numerous, whether plants can grow normally in microgravity or lunar gravity, how to handle pollination, the cost of lighting and energy, and psychological care. The calming effect of having greenery is also important. But if space agriculture becomes a reality, it will not only help with food self-sufficiency, but also improve the crew's nutrition and mental well-being, and supply oxygen, a 3-for-1 benefit, in a future lunar city. It might not be a dream to mass-produce wheat and potatoes in large dome-shaped farms, a sustainable model for living in space. Putting it all together, the circular model emerges: water from ice for fuel and air, oxygen and metals from regolith and food, oxygen and purified water from plants. The goal is a sustainable model for living in space that minimizes resupply from Earth. Of course, complete self-sufficiency is difficult. But if, for example, half of the food, most of the water and oxygen, and a portion of the fuel can be procured locally, the operational costs of the base will drop dramatically, and expansion will become easier. Furthermore, there are concepts for supplying resources obtained on the Moon to Earth or other locations in space in the future. If fuel made from lunar water were delivered to a space station in Earth orbit, it could become a satellite refueling business. If helium-3 can really be used, bringing it back to Earth could lead to an energy revolution. In that case, a lunar city would not just be a place of consumption, but a production city, a hub of the space industry, and could become economically self-sufficient. But perhaps I've gotten too ahead of myself. First, we need to perfect a system for humans to survive on the Moon, even on a small scale. To do that, we need to demonstrate the resource utilization technologies I've introduced, one by one. The latter half of the Artemis program and the Moon Village concept will be the stage for realizing exactly that. So, if a base or city is built on the moon and people start living there, what kind of life awaits them? In the next chapter, let's take a little peek into daily life in a future lunar city. A glimpse of life in a lunar city. Now, let's use a little imagination. If you were to live in a lunar city, what would your day be like? Let's simulate a day on the moon. Based on the life of an astronaut. A day in the life of an astronaut. It's 6 o'clock in the morning. Earth time. You wake up in the habitation module of the lunar base. Outside your window, you can see the blue Earth floating in the black sky. The Earth is always in roughly the same position in the lunar sky. And even at night, the brightly shining Earth illuminates the base. After getting ready, you go to the dome-shaped dining hall. Breakfast is a salad of lettuce and tomatoes grown in the lunar farm, bread brought from Earth, and coffee made from recycled water. You discuss the day's schedule with your crewmates while you eat. The morning is dedicated to base maintenance. You check if regolith dust has accumulated on the solar panels and inspect the status of the energy storage system and oxygen production equipment. Some equipment enters sleep mode in preparation for the lunar night. So you prepare for that as well. You put on your spacesuit and go outside through the airlock with a colleague. Outside, the sun is scorching hot on the ground. But thanks to your spacesuit, it's comfortable. In the 1/6 gravity world, your steps are light, and you can move around by hopping. This might be one of the fun parts of living on the moon. During your outdoor work, you also ride the new Lunar Terrain Vehicle, or LTV. It's a quiet, electrically powered vehicle, and you complete your inspection by driving around the base. Around noon, you return inside the base for lunch. Today's special menu is a lunar-grown potato soup, seasoned with spices sent from Earth. The afternoon is for scientific exploration. Since you are also a geologist, you go on an expedition to the rim of a crater, 5 kilometers from the base. You and a partner ride a rover, slowly making your way to the destination. Here, you collect samples of lunar rock and soil, mixed with ice, and record data with various measuring devices. Occasionally, you look up at the Earth through your helmet's visor and are momentarily captivated by its beauty. In the evening, you return to the base. Put the samples you collected today into the analysis equipment and send the results to the science team on Earth. There is about a 1.3-second delay in communication, but you can converse in almost real time. You have a video conference with the staff on Earth and plan the next day's exploration. At night, it's time for a virtual meeting with your family in the base's VR room. Thanks to high-speed communication, your family on Earth can interact with you through their VR headsets, as if you were in the same room. You show your child the moon's low gravity by jumping up in the VR space, saying, "A moon jump is like this." Your child is delighted. The day may come when you can meet on the moon for real. Before going to sleep, you go to the observation lounge in a transparent dome. It's a small dome made of radiation shielding glass, where you can safely view the scenery outside. Outside is the pitch-black lunar surface, and in the sky are a myriad of stars and the brightly shining Earth. The sun is beginning to rise from beyond the horizon, signaling the end of the long lunar night. Tomorrow will surely be another busy and exciting day. Good night, Moon, you whisper to yourself as you head back to your quarters. Possibilities for tourism and industry, and travel to and from Earth. Thus, the daily life of an astronaut is centered on scientific missions and base maintenance. But if a lunar city develops in the future, there is also the possibility that the general public could visit for tourism. Private space companies have already announced plans for circumlunar tours. And, in a few years, wealthy individuals might be able to circle the moon and return. There is even talk of building a hotel on the moon. Lunar tourism would offer unique experiences such as seeing the Earth rise and Earth set, the unique lunar landscape, and low-gravity sports like a lunar marathon or basketball, where you can jump several meters high as a lunar city grows. It will also take on the role of an industrial hub. For example, there could be a mining industry that transports helium-3 or rare metals from the moon to Earth, a space infrastructure industry that sends solar panels manufactured on the moon to space stations, or a space business that launches deep space exploration missions from the moon, setting the space economy in motion. The phrase commuting between Earth and the moon might not be a dream. Of course, a technological revolution is needed for ordinary people to travel to the moon routinely. But it's exciting to imagine a future 100 years from now, with terraformed lunar cities and Earth cities connected by rockets or space elevators. The sci-fi lifestyle of camping on the moon for the weekend and commuting to an office on Earth on Monday might not be impossible for humanity. In this chapter, we depicted life in a lunar city from the perspective of one space resident. While there are many challenges in reality, the very fact that we can now envision the future in such concrete terms with science and imagination is a step forward for humanity. Now, finally, let's consider the social and philosophical meaning that lunar settlement brings to us as humans. The social and philosophical meaning of lunar urbanization. Building a city on the moon is not just a matter of science, technology, and economics. It also poses profound questions for human society and philosophy. Here, we will explore this based on the theme of whether humanity can have two homelands. Having two homelands. Since time immemorial, humanity has evolved and built civilizations with Earth as its only home. That is about to change for the first time. If a permanent city is built on the moon and people come to call it their home, humanity will become a species with a home other than Earth for the first time in its history. This is a major turning point, both biologically and philosophically. For example, what if children are born and raised on the moon? For them, Earth would be their parents' homeland, and they would be people of the moon. Raised in a different gravity and culture, they might develop an identity different from that of Earthlings. From Earth's perspective, they would be the first generation of space immigrants, adding a new diversity to the concept of humanity. How will Earth-born and moon-born people view each other? New social relationships will emerge. There might also be a change in the consciousness of being an Earthling. Currently, the overview effect, the feeling of affection and solidarity for the entire Earth that astronauts experience when viewing it from space, provides a common human perspective. For the residents of a lunar city, Earth would always be a home, floating in the sky, and they would feel its beauty and fragility firsthand. They might cherish Earth's environment and peace more than ever before. At the same time, for those on Earth, the fact that there is a human community on the moon could change the consciousness among nations. It might symbolize the hope that humanity can prosper through cooperation rather than conflict. Impact on Earth's civilization, religion, culture, identity. A lunar city would also have a cultural and religious impact on Earth's civilization. For example, in terms of religion, major religious events, worship, and prayers are tied to Earth's solar cycle and cardinal directions. On the Moon, a day is 2 weeks long, and the direction of Earth is not always visible. How would the direction of Muslim prayer, the Qibla, be determined from the Moon? Which calendar would be used for the Sabbath in Judaism and Christianity? New theological discussions would become necessary, or there is the possibility that new religions could be born in the new frontier of the Moon. The very act of humanity advancing beyond Earth might force a change in the positioning of each religion. In terms of culture, a unique lunar culture would surely blossom. Low-gravity dances, the festivals aligned with the lunar calendar, artistic expressions inspired by the view of Earth. A new culture would be born, even if the common language within the base is, for example, English. Unique slang and technical terms would increase, and as generations pass, it is quite conceivable that an identity of "I am a Lunarian, not an Earthling" would form. Just as identity diversifies in immigrant societies, humanity as a whole would become aware of itself as a multi-planetary species. Finally, I believe a lunar city would give us both humility and hope. A person standing on the Moon would see the entire Earth and realize what small beings we are. At the same time, they would feel the hope and pride that such small beings have finally left their home to build a new frontier. This would surely have a profound impact on humanity's philosophy and values, and become a driving force to push Earth's civilization to the next stage. Conclusion and future predictions. We have looked at the plans, challenges, and future vision of building a city on the Moon from a broad perspective. Now, to conclude, I would like to summarize this theme and talk about the outlook for the future first. Regarding the timeline for realization, when asked, when will there be a city on the Moon? A conservative estimate would be between the 2040s and 2050s. As a possible benchmark, in the late 2020s, small-scale base construction may begin with the Artemis program. In the 2030s, a continuous base for 4 to 6 people. The Artemis base camp could be established at the South Pole, allowing crews to stay for several months. However, that is still the outpost stage. A city in the true sense, a settlement with infrastructure and a social system where hundreds of people reside, would likely require another decade or more of development. Perhaps in the late 2040s or early 2050s, a small town could be born on the Moon within the lifetime of our children's generation. Realizing this requires not only technology, but also international cooperation, funding, and a sustained will. There will likely be political shifts and delays due to circumstances on Earth along the way. However, once humanity establishes a foothold on the Moon, it will be one of the greatest turning points in human history. The moment we gain a permanent living space off-world, humanity will enter a new era of leaping into the cosmos. If a time comes when it's normal for people to be on the Moon, then migration to Mars and asteroids will become more realistic. Just as humanity learned to fly and migrated across continents 100 years ago, perhaps in the next 100 years, humanity will break out of the shell of Earth and spread throughout the solar system. Finally, having explored the concept of a lunar city, I ask you, would you want to live on the Moon? Do you feel the romance of leaving Earth to live in an unknown world, or does anxiety prevail? I think the answer is different for everyone. But what is important is how we, as humanity, face the prospect of building a city on the moon. This is not just a scientific challenge, but also a question of how we design the future of humanity. What impact will having a second home on the moon have on Earth and humanity? I encourage you all to let your imagination wander. Thank you for watching until the end. If you found this video interesting, please be sure to subscribe to the channel and give it a high rating. Also, our channel, Cosmic Lab, has been able to grow steadily thanks to the support of all our viewers. Thank you always for your support. We have set a challenging goal of 100,000 subscribers by the end of 2025 and are working hard every day to produce videos. If you haven't subscribed yet, we would be grateful if you would subscribe and continue to support us. We look forward to seeing you in the next video.